Good news for you Weight Watchers. Anything you've ever learned before about mass and weight is wrong, starting with their use in the English language. Every time they stop and think mass. I don't have enough mass, I need to bulk up on protein powder. You're talking about how heavy you are. You're talking about how big you are. Mass is how much stuff you have, everywhere where you wanted to use the word weight before. It talks about whether you are big, the heavyweight taco champion, or small, the featherweight taco champion. It fundamentally means how hard it is to push. Can you push it for 100 meters at a good solid run? If not, that's because it has a lot of mass. Mass is measured in kilograms. Weight is the force of gravity. It's not just a question of whether you're heavy or light. Think about it. If this fine sumo wrestler is dropped on your foot, how much will it hurt? Answer: not at all. The sumo wrestler's in space. If he's dropped on your foot, he won't fall. This is when we say that in space you are weightless. Not that the sumo wrestler has suddenly gone on a diet and lost 5,000 pounds and needs counseling, but simply that if he's dropped on your foot, it won't hurt at all. Weight, unlike mass, is measured in newtons. This is because it is fundamentally a force, not a measure of whether something is big or small. Gravitational potential puts the two ideas together. Of course your weight depends on your mass. If you're the featherweight taco champion, you are not going to weigh a lot. The other thing that weight depends on, though, is whether or not you are in a gravitational field. If even the heavyweight taco champion goes to space, she will not be all that heavy. In fact, she'll be weightless. Putting the two ideas together, here's our formula for weight. The force of gravity is directly proportional to your mass, m, and g, the strength of the gravitational field. We're going to measure the strength of the gravitational field in class, but in the meantime, look it up on Google. You'll need it to work your calculations tomorrow. Gravitational potential energy is your potential to fall and to do work on other objects when you fall on top of them and squish them flat. This depends on your weight, that is your mass in kilograms, g, the strength of the gravitational field in newtons per kilogram, and h, how many meters of height you have above the floor to fall from. Kinetic energy, the energy of motion, is the energy you need in order to move, or the energy you need to burn off in order to stop moving. You can visualize this in a similar way. How dangerous will you if it runs you over? Well, what determines how dangerous something will be to run you over? Well, its size and how fast it's going. If you are run over by a bicycle, this could be an oops, or this could be a hospital run, depending on how the bicycle is going. If you are run over by a Mack truck, you will be going to the hospital no matter how that truck is moving. Elastic potential energy, or spring potential energy, is the potential of a cock spring to shoot something across the room. This just depends on how easy or hard the spring is to load. If you shoot something across the room with a rubber band, you will probably not do much damage. Rubber bands are really easy to stretch. If you shoot something across the room with a hunting grade crossbow that requires a full body arm strength to load, then you will do some serious damage. Do not confuse lowercase k, the spring newtons per meter, with capital K, kinetic energy in joules. X is the stretch distance, how far you've stretched the rubber band, elastic, spring, or bow. Now you're ready to do some calculations with conservation of energy. Plug and chug!